Hi, everyone. Welcome back. My name is Ryan Boyd. I'm a developer advocate at Google on the cloud platform, and I'm serving as your MC here today. Next up, we have Chris from Google and Raphael from RightScale to talk about creating amazingly scalable games on the Google Cloud Platform. This pretty much ties together a lot of the technologies that we talked about in the first session of the day today. Ties together compute engine, app engine, BigQuery, and storage, all together to create games which scale really well. So, Chris?
Thanks, Ryan. That definitely summarized it pretty good. So my name's Chris Elliott. I'm a solutions architect on the cloud platform team. And what that is, it's kind of funny internally at Google. We're a very engineering-driven company, so I often get asked, like, what do you do as a solutions architect? People don't really understand internally. But essentially work with people, with developers, helping build massive distributed systems to leverage the power of the Google Cloud Platform. And specifically, I work very closely with a lot of game developers who are just doing, the amount of things you guys are doing is mind-blowing. Especially when you combine a platform like Google with amazing ideas. Every day I'm blown away by what people are creating. So this talk, amazingly scalable games on Google. And it really breaks down to three core messages. The first one is really speed. Speed not only in terms of development speed, of building up and deploying your game as quick as possible by not focusing on building out the core infrastructure, but also speed in terms of sheer speed of the platform. Technology like compute engine, developers are pushing it in amazing ways and really leveraging that powerful performance. Second up really is scale. Scale not in terms of the amount of huge resources Google has available. At Google I/O, we did a demo of how much that actually is, but also in terms of scaling correctly. If you only have 2 users and you're testing and getting the ball just rolling, you should only be using the resources that are required for 2. Vice versa, once you get to 1 million users, you need to be able to seamlessly scale up to that. And that's really the underlying message of the talk. And lastly, and most importantly, it's heartbreaking when you see amazing games with a huge amount of effort poured into them have issues at launch because they become successful. They're huge. Everybody wants to play them, and the back-end services cannot keep the game going. I mean, it's tragic. And it's really about surviving that unexpected success or surviving traffic that's way beyond your craziest expectations and being able to handle that so that everything works out smoothly. And on that sort of morbid side note, the game plan really is to go over Google Compute Engine, because that really is a powerful feature for enabling a lot of things developers need to do on a platform. Next up is really the main show. It's how do you tie together all of these components of the Google Cloud Platform to solve really challenging problems. How to leverage each of the components to the best of their ability to focus on solving the right problems and leveraging the technology to where it performs best. And then finally, when you're building on GC, RightScale is a very compelling technology to help solve some challenging problems there, and we'll discuss how that fits into the reference architecture as well as how people are using it in general on Compute Engine. So without further ado, let's jump into the Compute Engine overview. And with this, it's a service we announced at last I/O, and it's infrastructure as a service. You get raw virtual machines to run in Google's data center. And I mean, honestly, is there anybody in this room who would not want their code executing in a data center like that? That's absolutely gorgeous. I've seen some pretty crazy data centers at past jobs that just were not where you'd want your code running, and that is one awesome-looking data center. There might have been a little bit of extra lights added for the photo shoot, but nobody's confirmed or denied that yet. But really what you're looking at leveraging with Compute Engine is utilizing Google's scale, their speed, and actually one of the most impressive things is the global footprint. The fact that we have fiber connecting all of our data centers, you start to lose the concept of having regions that are completely independent. You can actually have really great performance between regions, and you can view it really as just an interconnected grid of data centers all over the world. And when you leverage that, utilize that, it's very compelling. And throughout this presentation, there are really 4 guiding principles that come up time and time again. It's consistency is huge. When you're building out on a cloud platform, if you do an implementation, a proof of concept, you need to expect that exact same performance from those instances, regardless if there's 1 or 100,000 instances spun up. And then with that, it's almost challenging some preconceived notions people have about cloud computing. There's some practices common on other platforms where you spin up 1,000 instances, you run performance tests, you see what that gets to disks, and if it's terrible performance, you throw it away. Don't do that on Compute Engine. You're wasting your time and money because the instance should perform exactly the same regardless of where it is, what's running on it. We strive always to go for consistency and have a consistent level of performance as opposed to a massive variable swing. And also, very important is security. I mean, also have not got anybody to confirm about the Stormtrooper in our data center, but actually R2-D2, I guarantee there'll be R2-D2s in our data centers. We're huge fans of robots, and even at my desk back in California, Mountain View, I have a Nerf robot that is telepresence controlled. I can drive it anywhere on campus and control my coworkers whether or not I'm in and out. So I would expect the exact same crazy guys in the data centers to be spending their spare weekends hacking on robots as well. So that's pretty much guaranteed. But really with Compute Engine, it's about allowing developers to do what they want, to be open and flexible, and really allow them to benefit from Google's proven technology. And so these principles come up time and time again. And gaming customers are noticing this. Kunal from Fiken Media was moving all their game servers to Compute Engine, and it was amazing. Our second time we talked, he came up and he's like, everything is just noticeably faster on Compute Engine. What are you guys doing? I forgot to mention the amazing network performance. And it's great when it's not a matter of looking at the logs and seeing millisecond improvement. It's actually in-game from the application. When you click on an action, it responds faster. It performs as you'd expect. And this kind of message comes up again and again from everybody we talk to. So it's really cool stuff what they're able to do there. And it's amazing when it's not even a placebo effect. It's actually people experiencing it and then telling you about it. It's great to see. And so, at a high-level overview, here are the 4 core components of Compute Engine. This is not a super deep technical overview of Compute Engine. I can talk for hours about all of these components, and if you're very interested in that, I'd love to talk to you afterwards. It's more of a higher-level overview, and if you're interested in much more detailed content, there's some great sessions from I/O last year. Look to this year's I/O as well, and also the developer docs. It has a ton of detail. So this is just a high-level overview of how the components fit together and what you look at. And so at the core of it is the Linux virtual machines that are running in the data center. That is the speed, the core performance. That is really the heart of the system. And the other technology is really about augmenting that and helping solve challenging problems by using that core raw computing power. And so on that, you're looking at 3 types of disk store for when you're storing objects or files, et cetera. Persistent disk is very common for mission-critical data. This lives beyond the life of the instance. And what's really interesting about persistent disk is performance is good by default. And also, it's consistent. The level of performance is exactly the same regarding when you're using it, how many you have, where they're attached. And so you can rely on that when building it out. And also, it's all encrypted by REST. And so it's some features that are really compelling that allow people to do things they haven't been able to do before as easy as this. The other option is local or ephemeral disk. And this really is if you need to write logs out, scratch disk. It lives and dies with the instance. And on that consistency note as well, if you have 4 cores, you actually have your own dedicated spindle. So you're the only project using that spindle, so you can rely on the performance of that as well. And but once again, it lives and dies with the instance, and we can never get that back, especially since all the data is encrypted at rest. And finally, the last really big component of the system is Google Cloud Storage. And this is, when you're building out large-scale distributed systems, this is really where you need to look to store game files, game binaries, all the assets there. Or if you have all these log files on your local disk, keeping them stored long-term in cloud storage to use for MapReduce pipelines later on. That's really how to think about these 3 core technologies and how they kind of fit together. And there's more on that later in the reference architecture. The networking. This is huge for gaming companies, and it's opening up new possibilities. The latency to connect to Compute Engine is fantastically fast. I can't believe I just said fantastically fast. I think I stole that from Michael Menicheri, who is up later. He loves using that word when talking about BigQuery as well. But that's an aside note, I guess. But the networking performance is great. And also within regions, the private network, being able to have a direct private fiber network between all of your instances and regions allows for very impressive throughput and very impressive latency. And so it's really, the technology's there to enable these new kind of experiences with gaming and also make ones that previously didn't fit great in the cloud actually work well. And the last aspect really is the API. And this is built on tried and true Google RESTful API, OAuth 2. If you've ever used any Google API, you know exactly what to expect here. And as we're Google, we build on top of that exact same API when putting together command line tools, building out libraries, et cetera. So it's robust, it's true, and it allows you to actually access all of these items as you would expect. And so that's really Compute Engine in a high-level overview. But really, as a solutions architect, the key thing is thinking that it's not just Compute Engine. When building out on the platform, you need to think about all of the different technologies that are provided to make sure you leverage the ones that are best for doing the job you're actually tackling. And so the Compute Engine interfaces with a lot of the other products we provide as well. For example, if you want to use task queues from App Engine, which was talked about earlier, or if you want to put files to cloud storage, the command line utility to do that is already set. You can have that set up by default when creating an instance. So there's a lot of seamless connections here, and we're always working to make that even more seamless in the future. And the last couple of parts on the compute engine overview really is giving examples of what people have seen that really put facts behind these things I'm saying. I could easily stand up here and say all these amazing things, and we get in, it's not what we experience, but this is actually what people are experiencing on the platform. This is from Ed at PA Consulting, and they work closely on a product called Chrome Jam. Has anybody tried Chrome Jam in the audience? You should try it. It's fantastic. It basically allows you to go in, you request a place to jam with friends, you send an invite to 3 friends, and you all get guitars, drums, etc., and you can all play real time with the instruments and have a jam session, essentially. And they've done a lot of work actually making that gameplay really fun. And so basically, this is the quote he said after trying it out on Compute Engine. It's like, our latency is crazy low. You should pat the Compute Engine team on the back for that. After I got this quote, I sent it off to the Compute Engine networking team and let them know that people are still appreciating the amazing hard work they're doing. It's blowing away everybody when they first get on the platform. And with this, an interesting note is they actually tried implementing this. The requirements for latency are extremely tight when they were dealing with real-time audio. And the fact of the matter is it wasn't possible on some other platforms to even run this technology, but it worked on Compute Engine, which was really, really cool. And this one is actually really relevant for gaming as well. MapR broke the Terasort world record on Compute Engine a couple of months ago. And what's really amazing and relevant about this is the fact that the previous record was held by data centers with dedicated machines in their own environment. And it was actually beaten by a cloud platform. Nobody would have expected this was even possible just because of past experiences working in the cloud. But that consistency, the performance, the networking allowed you to have all of your instances run. You didn't have any idle instances getting stuck or hung because of poor performance. Everything spun up, processed, shut down, and allowed them to smash this record with 1/3 of the number of cores. And so in thinking about building out game services, and if you're actually in that situation of do we want to build out dedicated capacity, seriously look at Cloud Platform for potentially allowing you to have provision capacity where the game is successful. If you end up having a bunch of capacity, I mean, you've probably heard this before in East Coast, and your game ends up being a huge success in Europe, but you don't have the capacity there, something like Cloud Platform is a perfect way to start scaling up once you've verified the core technology works great on the platform. And really the last one, this is an article that came out recently that when we saw it posted, everybody internally, we get really fired up about this when we see people externally excited about the platform. And this was from Scalar, Sebastian. He put out this article, and this the inter-region latency was under 23 milliseconds between 2 regions. And that actually opens up possibilities. For example, if you're doing real-time gaming, if you're over 90 milliseconds or near 90 milliseconds, by the time it hits the player, their latency is going to be so high, it'll remind them of being back on 56K modems, and nobody's going to play that. But if you actually have 23 milliseconds between data centers consistent, that allows you to actually do some new things there as well with actually connecting the instances across zones. And also, if you look at the bandwidth is off the charts, 300 megabits per second. And that's really, once again, telling the story of the Google global network there. And this one, although it technically doesn't affect the core performance you see running the game servers, the time to boot up instances is exceptionally fast. And I can't honestly, I was talking to Raphael from RightScale, who's going to come up later, and I couldn't remember the last time I actually sat around waiting for an instance to be provisioned. I go on the web UI, I spin up some instances. By the time I get my terminal up and go to SSH in, the instance is already there, ready to go. So it's kind of new ways of thinking that are really being observed as well by people when they get up and running. And so some of you may have tried for Access. The response has been overwhelming, but game developers are a fantastic fit for Compute Engine. It's currently limited preview, but if you'd like Access, either talk to me right afterwards, we can get you in. Game developers are a perfect fit for the platform. Otherwise, sign up for the newsletter, follow the blog, check out cloud.google.com for the latest updates, or send me an email after the fact if you have an interesting use case. It's just great to hear from game developers, and we can definitely get in the platform. I wouldn't be up here talking about Compute Engine, how amazing it is, and then not let anybody in. That would be ridiculously evil. And last time I checked, we weren't an evil company as of yet, so it's pretty good stuff. Not that we ever plan to be. So with that, this is really the main course, how do you tie all of the components together to solve a really challenging scalability problems faced by game developers? And with that, we had to find a game to demonstrate this on, and this was a perfect candidate. There's a game called Grit that they showed off at I/O last year. It was fantastic. It was player versus player, real-time, Node.js on Compute Engine, using HTML5, and it was meant to show off that, the performance of what web technologies can actually do. And so we took this core game that had some scalability built into it and applied a lot of the core concepts from this reference architecture to this existing game, which Google owned all the source code, so it made licensing not a problem at all. Actually, Fred in the audience as well worked on some of that as well. And so there's an amazing point to start to demonstrate this huge amount of effort spent creating this game, just a little bit more, an extra week or two, you can start to apply some of these concepts to allow this to seamlessly auto-scale in the background and handle a huge amount of traffic. And so it's a top-down robot shooting game. It's awesome. Check it out if you have a chance. There'll be more links to that at the end. And so this gaming reference architecture really is about creating real-time multiplayer on dedicated servers. Having your own binaries running on Compute Engine, providing low latency, TCP, full duplex connections to handle all of that streaming, running whatever existing software you want, while providing the scalability to go up to millions of users, handle a huge number of incoming requests. And really it's about building a full-featured gameplay experience. It's about having a store, having a marketplace, having things to draw players back, and thinking about the whole package. And this also, it ties together all the components of the cloud platform, like Ryan mentioned, from using App Engine to handle a lot of the user-facing scalable aspects to having, if you have 100,000 servers and they need to actually connect to a source of truth, using App Engine for that and scaling as well accordingly. And then things like cloud storage for large object store log files, BigQuery, which is an amazing tool for real-time analytics of ridiculously huge data sets. And we actually don't use Cloud SQL in this as well, but it's exactly what you'd expect from a managed SQL database. And so if you're really familiar with that technology, you have a good use case that fits within the scalability constraints of MySQL. It's a great fit there as well. So to get started, you have to have a game client. I'm sure there's no surprises here. The only question I've got, actually, we didn't have time to change it, is like that Android phone looks a lot like an iPhone, completely accidental. But so it's really about, regardless of whatever phone you want to use, whether it's iOS, Android, you can have an Android application, or if you are developing console games or games running on PC clients, or if you're just a web browser game, regardless, you have to start somewhere with the core gaming aspect and building out that client, whether it's downloaded or obtained over the web. And so for Grits, this is what was provided by the existing product. And so there's an Android application. This just shows you the controls. And then there's also, when you connect to the IP address there, you're pretty much good to go. And you're jumping in and playing a server connected. And you pull all the data content from the server as well and play it all in the browser. That was a really awesome thing about Grits. And so once you have the client installed, you have to go in and find a match. I mean, as everyone in the audience knows, server matchmaking can be ridiculously challenging. Depending on the techniques you use, the ways you go about implementing it. And the key aspect here is really leveraging the scalability of App Engine. We highlighted a lot of this in the keynote and the key components here, but really it's technology like the App Engine Data Store, which is a huge NoSQL database built on top of Megastore that can scale up to serve millions and millions of users. I mean, at last I/O we said it was over 2 trillion operations per month, I believe, or per week. And I mean, that, as you can expect, can continue to grow. And so that is one of the key components to build out a lot of this logic. Additionally, when you put Memcache on top for a lot of real-time accessing, if you have server data that's frequently accessed, Memcache is a free layer to put on top of that to help scale up there. And also, if you're doing a lot of background processing, if you're keeping lists of servers under certain categories updated, you can use things like task queues and background processes for that. And so really, those are the core technologies to use when building out the logic. Whether it's something like having all of your servers maintain health checks with App Engine and having that status all stored in the data store for future reference. At the end of the day, it's about what do you return from the server matchmaking. Whether it's a simple, quick match, give me the best match with players of my skill, or they're actually looking at building out something that returns a large list of IP addresses to the client to allow them to find the low latency ones that are close by. That's really the core aspect there of server matchmaking, and there's lots of interesting techniques if you want to talk about that after the fact as well. And actually, cloud endpoints here as well. It's kind of funny in this diagram, having a cloud and then leaving the cloud. All the right-hand side is in the cloud for the most part. But cloud endpoints is a fantastic technology for having a strong RESTful API around App Engine to provide a way of scaling out, to have authentication built in. And there's also libraries available for all the Android, iOS, JavaScript as well to make that really easy and seamless to get up and running with these powerful RESTful APIs. Because a lot of people building on App Engine put a RESTful API, and now that's provided to you, leveraging Google's experience building out these APIs. And so for Grits, we took a reasonably straightforward approach to implementing this. And so this is what we added to the existing application. So essentially, when you log in, you either can do a quick game, just give me a server that has players on it, or you can also see a list of all the servers you have here. Right now there's only 5, but as this scales up, the servers are added to the bottom of the list. And so you can currently see the IP addresses, how many players are currently active. You can go in and access the admin as well. So it's fairly basic, but it gives you a general idea of how App Engine is the spot you go to get matched with your server, and then from there, once you have that IP address, you directly connect to the client, and you're good to go. And so the next aspect, and I mean this is, as game developers, where the majority of the effort should be focused, is building those really compelling experiences running on the dedicated servers, having the full, running whatever existing software you have, the game engines that you develop on, having that full connection. I mean, this is where the player is going to spend the majority of the time, and having that deployed across regions is really compelling. Actually, a note on compute engine as well, the consistent performance is really important for dedicated game servers. When you're looking at the situation, if 5% of your servers aren't performing well, 5% of your players are going to have a bad time, and most likely some of those will actually be very vocal about it, and it's not going to be a good experience overall. And so by having that consistent performance, it allows you to deploy 100,000 servers and actually know that that performance will be what you expect, and you can sleep safe at night for that one aspect. Building scalable systems is hard, but the end goal is to really allow developers to sleep better at night and have Google engineers and SREs on call for a lot of the scalable problems that are involved with building out large distributed systems. So on Grits, this is exactly what it looks like after you click on one of those IP addresses. You'll see that actually you probably might not be able to see it, but the address bar is now the actual IP address of the server you're connecting to. You could put DNS on top of that if you wanted. Otherwise, you're directly connected to the compute engine server, running Node.js, pulls in all the assets, and you're pretty much good to go, respawn, run around with up to 8 other players and start having fun. It's actually really funny. Every time I show this off, I was presenting at Google, and there's about 50 people there. And afterwards, I noticed there was about 40 people in the servers, and so I felt pretty bad for the guy in the talk afterwards, because everyone was on their laptop actually playing. So I had to kind of shut those down to be nice, but they were back up after the fact. And so this really highlights the source of truth aspect. If you have 100,000 game servers and you want to do things like save end-of-match statistics, being able to post those to App Engine through cloud endpoints and the RESTful API that's provided and store those long-term in the data store is a really important aspect there. And the data store is fantastic when you're scaling up to millions of users. The underlying Megastore technology, that's its bread and butter, is scaling to millions of users, storing all of that data in a way, and having cross-user transactions, et cetera, when you start looking at user groups. And so this can also be as simple or as complex as you want. If you actually want to build it up that every single player action is sent off every second to App Engine can scale up to handle that. The thing you need to think about is actually scaling up to handle that takes a lot of resources, and Cloud Platform, it's pay by resources. So you need to really understand the costs associated if you want to make those engineering decisions. Otherwise, things like if you have a store and you have a free-to-play model, keeping track of everything that's happening there, making sure that if a player has a customization on their client, that they actually have purchased the required components and have the rights to use them. And so that's really where App Engine provides a scalable infrastructure to handle any of those in-game requests. And the last aspect of App Engine really is the virtual machine orchestration. If you're running 100,000 game servers, you need to start thinking about, well before you had 100,000. Otherwise, that's going to be a lot of SSHing, and it's going to be a massive team. But you really need to think about, how do I scale this in a way that makes sense? And so if you have a region that is running out of capacity, how do you utilize, sorry, throat's a little bit dry up here. You utilize the GCE API from App Engine to call out and create more instances. Similarly, if players are not currently active, you can pull those instances from server matchmaking. Once all the players leave, you can also turn that down through the API. So App Engine can really be used to build out that orchestration component because it also scales up to, if you have 100,000 machines giving heart, basically checking in, the infrastructure can scale up to handle that number of requests. And it can be as complex or simple as you want as well. So you could have an API console, an admin console. We go in and say, give me another 100 instances, or you can do some auto-scaling. So with that, with Grits, we did a fairly straightforward auto-scaling algorithm here, where essentially once capacity, this is the admin console, by the way, and once capacity reaches a certain threshold within a region, new game servers will automatically be spun up and added to the rotation there. So it starts off with 5 by the default configuration, but I've scaled this up 20, 30, 40 servers. very easily, and I haven't had a chance to actually push it, but I mean, the underlying core infrastructure of spinning up those servers is exactly the same and repeatable all the way up to 100,000 servers. If you start hitting 100,000 with this sample application, you'll start to need to do a little bit more tweaks with server matchmaking, just not to provide a list of 100,000 servers to players. That wouldn't be a good experience. But the core fundamentals of scaling and showing what that looks like from App Engine is provided by the sample application here. And so this is the last aspect of the solution, is the past component was really about the gameplay experience and what players take. I feel bad for people taking pictures. There's one more part added to this. So unless you want to go through the pictures and slowly see it build itself magically. The last aspect is you're going to have a huge amount of data being generated on all of these game servers, and this log data can be very valuable for a lot of business decisions and even understanding what your players are doing. And so taking those logs from ephemeral disk and keeping them permanently stored in cloud storage, which is a large online object store, is a great place for those logs to live for a long time. And what people are doing is essentially then taking those, running MapReduce pipelines on it to aggregate it down to a level they actually care about. So for example, if you have every single player action per day, that is a huge amount of data that you're not going to be able to wrap your mind around. But if you take it down to actions per player per day and not every single actions, it starts to get to a level of granularity you can actually start looking at. And that's really where the next thing, wrong way in the slides. This is the final thing here. This is really where BigQuery comes into play as well, which is a real-time tool for doing analytics over billions of rows of data in real time. We're talking seconds to return. And so you can do things like A/B testing or see what the effect of a double experience weekend is on player engagement. You can do a lot of these queries that you don't really have off the top of your head right away and build your MapReduce pipeline, but you can do after the fact ad hoc. And before joining the cloud platform team, I worked on AdSense at Google. And this was my bread and butter, building out these MapReduce, BigQuery. They really are a dynamic duo that can solve ridiculous, scalable big data problems. And so with ads, for example, looking at all of the ad traffic per website per day, and then being able to go in and look at a huge range of sites every day, or look at things like how partners are performing, being able to go in after the fact and troubleshoot if specific sites are not performing as expected. So it's really powerful. And the session happening after this by Michael Minicheri will provide some more insight to what people are doing with BigQuery, because it's absolutely amazing. And so this slide is going away slowly for anybody else who... it's actually also published online if you want to look at it. There'll be a link at the end. So, and that's just really highlighting some of the core functionality, but really it's about building a full-featured gameplay experience. Having user profiles, configurations, seeing after-match stats, looking into how player configuration, go in, build out your mechs as necessary, and starting to build in some social aspects, events, news feeds. If you're free to play, you're going to need to have some marketplace, even if you're not, to allow players to keep that engagement, to highlight really interesting things they can purchase, and build that into the core game logic, and start to build up friends and favorites. I mean, there's a million different ways you can build a full-featured gameplay experience to keep people coming back, and the platform of App Engine and Compute Engine can really scale to handle that and allow you to build that out in a way that you can be rest assured that it's going to scale out. And so, regarding grits, there's a dedicated game server solution paper I put out. It's available on cloud.google.com resources. You can find it there as well as other ones our team's producing. Also, the sample code is going to come very, very, very soon. We're literally about to press the button on it. And so keep an eye on the GitHub Google Cloud Platform for all the samples there, and to keep an eye out for the scalable grits example put in. And so now, I'd like to introduce Raphael on stage, talk a little about RightScale, how they play into this. He's a senior systems architect at RightScale as well. And so when looking at just that past example, by the way, anybody impressed with this? Is all Google Docs. I mean, this is Google presentation. I wanted to give the audience 3D glasses, but marketing didn't really approve of that. So, but really, when looking at RightScale, this is where one of the examples where it can come into play to solve some amazingly challenging problems with scalability. So, orchestrating virtual machines can become very complex as you scale. And although you could build out an app engine, if you're familiar or you want to leverage tools like RightScale, it's a perfect place to come in and start managing, scaling up all of these game servers in a way that's repeatable, easy to monitor, easy to manage, easy to just overall keep it up and running with speed and leveraging the performance. So on that, hand it off to Raphael.
Thank you, Chris. So I'd like to start with a quick overview of RightScale since some of you might not know about it. So RightScale was founded in 2006, which in cloud time is prehistory. And what that means too is that RightScale really believed in the cloud vision since the beginning. There are currently thousands of paying customers using RightScale and more than 70,000 users worldwide. We do have a free tier that's very popular. And about 5.5 million instances have been launched through the platform. And what's interesting with that number is that 2 years ago, it was 1 million. So it took 4 years to launch the first million instances on the platform, and in 2 years, 4 million more were launched, which took to the exponential growth of the cloud consumption. RightScale is also the first SaaS management platform which has solutions built specifically for the gaming industry. And so what that resulted in is basically RightScale has become the de facto standard for running gaming infrastructure on the cloud. 15 of the top 20 Facebook games run on top of RightScale. Games like Angry Bird, Cityville, Farmville all use RightScale as their management solution. And one of the things that I really enjoy working at RightScale is seeing all the crazy things that our customers build on top of the platform. And the gaming industry seems to be some of the more creative folks. And so we see people really taking automation to the extreme and be able to manage, achieve ratios of 10,000 servers being managed by one sysadmin, which is amazing. So why is it that game developers choose to use RightScale to manage their infrastructure? So this is drilling down to the technical aspect of the platform. And basically what the platform lets you do is write code that gets run when an instance is launched in the cloud on that instance. It also lets you run the code that's going to get run when the instance is shut down or when some interesting events happen. And the platform also lets you define what those interesting events are. So it's going to use, the platform is going to collect monitoring data in real time, and you can use that data to create events. So it could be that the CPU is running hot, or you're running low in memory, or low on disk space, and when those things happen, then you can trigger some code to run on that instance. It's also possible to extend those metrics, so you can have application-specific metrics, like number of requests per second or number of reads per second, and use those metrics to trigger execution of code on those instances. So if an app server hasn't gotten any requests in the past 2 minutes, then there's certainly something wrong with it, and you can actually do something about that. And finally, what RightScale lets you do is take all those rules, all those alerts, and all this code, and wrap that into a single unit, which we call a server template, and lets you share that server template across your teams. So if you have an organization that's building multiple games, and that have similar infrastructure requirements, you get to actually share a lot of that code and a lot of that configuration logic. That code is also, you can also publish it in the marketplace, and I will cover that in a few slides, where you can actually have external people from your organization import that code as well if that's something that you need to do. So once you have crafted those server templates, encapsulating all that code and all those alerts, you can use that to leverage auto-scaling by launching servers that execute the code on the server template. And the way this works is, or the way auto-scaling works, is that those same alerts that you use to trigger the execution of code when things happen, you can also use that to trigger votes. So an instance can vote to scale up, for example, if the CPU is running hot, or can vote to scale down if it's idle. And then you get to choose the threshold, how many voters need to be voting before scaling even happens. And when the scaling even happens, you get to choose how many instances should boot or how many instances should be shut down. And there's all kinds of other levels of knobs that you can turn. You can pick which data center those instances should be booted in, and all kinds of other settings that you can specify through both the dashboard and the REST APIs. I mean, I have some pretty pictures here on all those slides, but all of that functionality is also available through our REST APIs. So the monitoring data that is used to trigger those events is also used to plot graphs. So you get different kinds of graphs. You have simple graphs like the one shown here. You can also get stacked graphs that works well if you have 100 or less servers. Past 100 servers, stacked graphs start to get a little bit useless, and you want to use things like heat maps. So we have also heat maps where the color of the pixel indicates the intensity of the metric. The other thing that RightScale lets you do is get notifications when those alerts triggers. So you can get an email, you can get paged, you can get woken up at 2 a.m., all those great things. And it also lets you run those scripts on demand. So it's not just pure automation. You can actually say, OK, I need to back up this database now. You can click the button and take a backup now. And once you have all those servers running those server templates and those server arrays, you can organize all that in deployments. And what RightScale lets you do then is once you have those deployments is you can clone them. So you can have your production deployment, and you can clone that, and then have QA use that clone to run their test code. And if you have to test a different branch, you can clone that again and launch in the cloud and run that different code. So it's very powerful. So going back to the marketplace is a repository of pre-built server templates. And so I was counting them to prepare for this presentation. And as of March 21st, we had a bit more than 60 server templates built for GCE. And actually, those server templates will run on multiple clouds. And 20 of which were published by RightScale. And what that means is that they are supported by RightScale. So if you have issues running those server templates, those tags, you can actually send tickets, and we will look at that. And the other thing is, because we built them, these are the same server templates that the people running Cityville or Angry Bird are using, right? So these are things that have best practice built in, and you get to leverage a lot of that knowledge right off the bat by using those. And they cover all the different tiers that you may use: database, application servers, front ends, and other things like syslog, memcache, or all kinds of things. And we also have a lot more server templates that are going to get ported to GCE little by little. We have a bit more than 400 server templates in the marketplace, and they are all going to get ported to GCE little by little. So at the end of the day, what all that means is that you spend less time managing your infrastructure and more time actually on your games, which is what you want. Some of the easiest sell we have at RightScale is when somebody has tried doing the VM orchestration piece by themselves, right? And realize after 6 months of development that it's going to take another 6 months and that it's not worth the effort. Might as well just go with a company that just does that as a living. So going back to GCE and Google, today GCE is completely integrated within RightScale. So all the features that RightScale provide are available on GCE. And that's really awesome because you get an incredible infrastructure, and on top of that, you get the flexibility and the power of RightScale. And one little anecdote here is about 3 weeks ago, we released a new revision of our server templates. And that meant that we had to launch about 1,000 servers to test all the various combinations of clouds, platforms, software stacks, so MySQL using Ubuntu, MySQL using CentOS, all of those different combinations. And consistently on all those platforms and all the software stacks, GCE it has been the faster cloud. So I think it's a testament to the quality of the cloud. Now you get that quick setup that the cloud provides you with, and on top of that, you get the ability that RightScale provides to clone those deployments, and you end up with something that is really powerful, where you can take your entire infrastructure and duplicate it in minutes, right? That's basically the time it takes to clone and launch. About 2 minutes, and you have your entire infrastructure just replicated and available for testing. And because it's running in GCE, you get to publish your assets to YouTube, Google+, and other Google properties without being charged for bandwidth, which can be significant depending on what your game needs to do. And I am pleased to announce that as of today, the RightScale Social Gaming Edition is actually available on GCE. So this is the same edition that all those other games I mentioned have been using. And what you get with that is both a set of software stacks pre-built, server templates pre-built for you to use, but also, and maybe more importantly, you get support and services from RightScale. So you get an onboarding package where you get to work with the same people that have worked with those other games. So you get to leverage a lot of expertise right off the bat. We also include some jumpstart training so that you get quick started on RightScale and using the cloud if you need that. So I think the website is being built as I speak, so it's not available just yet. So check back on RightScale.com during the week. It should be there in the next few days. In the meantime, you can contact me, or there will be an email address in the next slide that you can send an email to if you are interested in subscribing to this program. And I think this is it.
Awesome. Yeah, in a nutshell, and to really wrap it all up, what we've seen is Google Cloud Platform is the best place for cutting-edge developers. Whether it's an indie or a AAA game studio, there are people doing amazing things by leveraging the power of the platform. And really, next time you're going out building a platform, or if you're already on the platform as well, just keep thinking about how you can integrate all of the components to solve the extremely challenging gaming problems that we see every day. So that's basically it, and we can take any questions, and please reach out to us if there's anything else you're interested in. Yeah, feel free to use the microphone in the middle if you have any questions. Otherwise, just raise your hand and I can repeat it as well. All right, no questions. That's a first, I think. Well, thank you, everybody. And keep an eye out for the other tracks as well.